whiteboard na? Microsoft whiteboard. আচ্ছা এই ওদেরকে একটু আস্তে করে কথা বলতে হলো তো ওদের Hello. Hello, this whiteboard is visible to you?
Yes, sir.
Yes, sir.
Okay, but where is the problem? Automatically, let me check it. Oh, why this is coming automatically? Let me what's happening? Something creating problem here. it automatically has to, let me check it. No. Okay, আমাকে এখন this is Microsoft Team. This is desktop and cannot display content. But when I am just clicking on this, it's not coming. Why?
So you can share your OneNote with drawing on or something like that. Share your screen then.
Once again, I'm trying. Whiteboard. Okay. Then yeah. No, it's okay, na? It's
Yes, sir.
okay.
Sir.
Yes, sir. Yes, sir.
Whatever I am writing, it is visible to you.
Yes, sir. Clearly.
Yes, sir.
Okay. So today, actually, I think in your last class, which was taken by Shandip sir, it was on basically analog signals, continuous time signals, and I will take the discrete signal part. Okay. What are the different types of discrete signals? What are the features of discrete signals? How we can measure the frequency components of discrete time signals? How we can process the discrete time signals? We can use some operation on discrete time signals, different types of operations, and then Again, some transformation techniques are there which can be applied to discrete time signals for manipulating the signal, and the systems which can handle the discrete time signal, that will also be discussed in this part, that is discrete time systems. And then we will apply the transformation techniques to analyze the discrete time systems, whether the system is stable or not. That can be analyzed by using the transformation techniques. So these are the basic parts of discrete time systems. Let us see what is discrete time signal. Already I have this, when I was discussing about the category of the signals, then I was discussing about the continuous time signals and discrete time signal and the difference between these two. Now, let us once again, I will start, let me start from that part. Suppose the signal is like this. Here, I will consider one-dimensional discrete time signal, and at the same time, I will think that the horizontal axis that will be represented, this horizontal axis will be represented by the time variable, and here, in place of time variable t, I will write n. Okay. And the signal will be considered as a function of time, and here xn. Why I am writing n? Actually, n is here integer, and the intersection between two axes is your origin. Now, discrete time signals will be like this. At each and every instant, the signal is not defined, but the signal is defined for some discrete points. And these discrete points will be represented by discrete variable n, integer variable n. This n is integer actually. So for n is equal to 0, suppose this is the this red sample. Okay, this is one sample. This red sample is one sample value, and another sample. Suppose this is another sample here of the signal for n is equal to 1. This is for n is equal to 0. This is for n is equal to 1. And you can think of another signal like this. You can think another signal here like this. And what I am thinking, that these sample values are regularly spaced, means the distance between two successive samples are equal. If you think about the distance between these two samples, suppose this distance is, for example, I am giving one parameter. I am assigning one parameter to measure this distance between two successive samples in terms of time, and it is suppose Ts. This is called sampling time period. And here also, the distance between these two samples is Ts, and again the distance between these two samples is also Ts. This is also Ts. The distance of these two samples is. That means I want to say, wherever you will take two successive samples in the time, in the defined time range, then you will get the distance will be always this Ts, and this Ts is called sampling period. Okay. So this is again for n is equal to -1, some sample value may be there. N is equal to -2, some sample value may be there. So this is your one signal that is represented by xn, where independent variable n is integer, but this xn, this x, the dependent variable, this is not integer. This is not always integer. This is a real number, and this signal is called discrete time signal, because the signal value is defined for discrete points. It is not continuous. Okay, and that's why it is discrete time signal. Clear? Now, discrete time signal may be periodic, may be aperiodic. Okay. Different types actually. It may be energy signal, it may be power signal. When it will be energy signal and when it will be power signal, that is also defined based on the amount of energy or power. amount of total energy or amount of average power. And this discrete time signals may also be like this this deterministic signal. It can also be classified as this deterministic signal or random signal, as we have discussed earlier. Okay. Anyway, those classifications will be valid also for this case, for this discrete time signal also. Now, I will discuss about the characteristics, means frequency characteristics of the signal. Frequency characteristics means what I can say. You know, if I think about one continuous time signal, just I am showing here. Then suppose the signal is giving like this. Ax t is equal to some constant amplitude a cos. Suppose here I am thinking some omega t plus some angle theta. This variable t is continuous time variable. Okay, and suppose the range of t is given like this: minus infinite, less than t, less than infinity. Okay. Now here the signal is periodic or aperiodic. Can you tell me? Generally, we know that this omega in different books, different representations are there. In some books, you can see that this representation, it is represented by this kind of omega. Okay, but here I am taking this omega because I will use this type of omega for digital signal. This is for continuous time signal. Okay. Now, here, this omega, this capital omega, this I can write this is equal to twice pi into some frequency, you can write, suppose capital F. Then this capital A is called frequency for this time domain signal. Frequency, and the unit is hertz. This is frequency.
So omega is equal to 2 RF.
2 pi f, pi.
Pi, okay.
Pi. Let me write it clearly. 2 pi capital F. Okay. This F is called actually frequency, you know. And here, this signal is periodic signal. And I think you know what is the definition of periodic signal. It will repeat after every period. Okay. So sometimes this F can be written in this form, 1 by t, where t is the time period. Means actually, after every t, the signal value will repeat. Okay. This is for continuous time signal. Now for discrete time signal, what kind of frequency, how can we think of this frequency and other things for discrete sinusoidal? This is for analog sinusoidal. This is analog sinusoidal signal. Analog or continuous time, you can say, let us write, it is more appropriate if you write continuous time. Continuous time sinusoidal signal. I am writing here, just I am erasing this, removing this part, and you can write here signal. Continuous time sinusoidal signal. Clear? Now let us see, what about this discrete time sinusoidal signal? Discrete time sinusoidal. A discrete time sinusoidal signal can be expressed as actually xn is equal to some constant. Just I am representing the signal as a cosine. Cosine. So this is cosine is also sinusoidal. Cosine and sine function are two functions are sinusoidal. So you can write this as some cos. You can write here omega into n plus some angle. For example, I am writing theta. Here you see, for this case we are using this lowercase omega, and here n is integer. Okay. So what we can write here, omega is equal to some twice pi into f. This is pi. This f is frequency variable. Clear? Now this is valid for here. Again, I can write that this less than for this range. Okay. Since n is integer, for example, let us consider that pi has a specific value. You can consider this as 0 also. To understand easily, you consider theta is equal to 0. In that case, xn, if theta is equal to 0, theta is equal to 0, then xn will be, this is the initial phase actually. Then xn will be a cos omega n. Now, if the value of omega is given to you, then you can plot n versus xn. For different values of integer values of n, you can evaluate the value of xn and you can plot. And in the plot, the vertical axis will be xn and horizontal axis will be here n. Then you can plot the signal. Obviously, if one wants to plot, if you want to plot this, then just I will show what may happen. Okay. This sinusoidal signal. The shape of the signal is obviously dependent on the value of omega. Okay. Now, for a particular value of omega, for example, after drawing, I am seeing that the signal looks like this. Just first, I am drawing the signal as a dotted line. Then I will just it is like this. So number of samples, whatever I am drawing here, that this may not be in actual situation if you draw. However, just to give the idea, I am drawing in this way. Okay. So this will be safe. So here number of samples will be more because the density of the number of samples here and here, they are not equal, but they will be equal. They will be equally spaced, though it is not actually properly drawn in this picture. Okay. So, and this is your xn and this will be your n. This is for a particular value of omega n. Then if you change the value of omega n, then the shape of the signal will vary. I will show you for what values of omega, what will be the actually graphical nature of the signal, shape of the signal. Okay, I will show you that later. Now, next I want to say that suppose this is a sinusoidal signal. I am saying that this is a sinusoidal signal because it's a cosine function. Okay. Now, Can you say that this, in case of discrete time signal or sinusoidal signal is always periodic? In case of continuous signal, suppose here a continuous signal is like this, xt is equal to a cos omega t. I am writing omega t plus theta here. Now, what is the condition? Is it periodic signal? All of you will tell. We will
Yes.
respond that it is yes.
Yes,
It is
sir.
periodic signal. Huh?
Yes, sir. It's a periodic signal, sir.
Yeah.
Yes, sir.
What is the period of this signal? I know. The period of the signal can be determined if we know the value of the time.
Omega.
So if you know that omega is equal to twice by t, and if the value of capital T here, capital T is known to you, that means this is time period. So after every capital T, the signal will repeat. Isn't it? Yeah.
Yes, sir.
Okay. Now here xt plus capital T is equal to a sine, cosine omega. I am giving third bracket here, t plus capital T plus theta. You can write in this way. Okay. Then now it is possible for you to prove that this will be equivalent to this. This will be equal to this. Now you know the definition of periodic velocity. If we see that xt is equal to xt plus capital T, t plus minus capital T, there I will say that this signal xt is called periodic. And the minimum value of t for which this particular equation, this particular relationship is valid, that is called the period of the signal. Okay. So you check whether this will give you xt or not. If you get that this value is equal to the xt, that means this value is equal to this value, then you can write that xt is equal to xt plus capital T, so it will be periodic. So in this way you can prove whether a signal is periodic or is not, or it is not periodic. In case of analog signal, you can do so. Now in case of discrete time signal, xn is the cosine signal is represented by xn cos omega n plus some theta. Now, what is the definition for periodic signal in case of discrete time signal? I will define it first, then I will try to understand whether this signal is periodic or aperiodic, or whether it is always periodic, or there is any chance that it may be also, though it is cosine function, but it is not always periodic. It may be aperiodic also. It may be non-periodic also. Okay. Now here the definition means the definition of periodicity I will write here. A discrete time signal, I will write dt signal, abbreviated from discrete time signal. Okay, and here it is, since it is a sinusoid, so I will write dt discrete time sinusoid signal. Sinusoid is periodic. That means actually a discrete time sinusoid signal may also be non-periodic. I want to say is periodic only if its frequency write clearly. Its frequency if is a rational number. I will prove it. What is f? Actually, I told you that omega is equal to twice pi f. This is the frequency variable. Okay, you can say frequency parameter. Okay. So let us try to understand why I am telling that a discrete time sinusoidal signal is periodic if only if its frequency f is a rational number, is a rational number. Okay. Rational number means, actually, all of you know, f should be represented by some a by b, where b not is equal to 0 and a and b are two integers. Then f is called rational number. Okay. B not is equal to 0. Now, this f should satisfy this condition. Then f will be rational number. And if f is rational number, then you can say that this sinusoidal function is periodic. Otherwise, it is aperiodic. Non-periodic. Okay. So what is the condition? Sorry, it is n. Okay. The condition is this, that this f, which is included in this within this omega, that f should be rational. When f is rational, then this sinusoid is periodic. Otherwise, it is not periodic. Okay. Let us see how can I prove that. Now, basic definition of, suppose xn. This is actually for periodic discrete time sinusoidal signal. In that definition, I have written. What is the condition that a discrete time sinusoidal signal will be periodic? For that, I have written. I had written the last sentence. But the general condition for a signal xt. Suppose xt is any arbitrary signal. Xn is any arbitrary signal. Suppose xn is any arbitrary signal. Then what is the condition that xn will be periodic? The answer is this: xn will be periodic if xn plus capital N is equal to xn for, I can write here in this form, for all n. And here, capital N, this is called period.
Time period.
And this capital N should be always 0. So the signal xn will be periodic only if periodic with period n. You write the signal xn is a periodic signal with period n, even only if xn plus capital N is equal to xn. This xn is the period. Okay. So this is the condition for periodicity for any arbitrary signal. And the smallest value of n is called the fundamental period. The smallest value of capital N for which this equation, suppose this is equation number 1, for example, for which equation 1 is satisfied, is called the fundamental period. Sorry. Okay, this is called fundamental period. Now you see, suppose our signal is cosine signal. Just here I am writing. I am just thinking that this A is capital A is equal to 1. Suppose capital A is equal to 1, means the amplitude of the signal is 1. Okay, so this capital A cannot influence the periodicity because it is amplitude parameter. So suppose the signal is here, by considering that A is equal to 1, here you check. suppose sine twice pi f here. Let me write here in this place. Cos, here you write twice pi let us consider I am thinking that omega is equal to twice pi f0 for this particular signal. So otherwise you can write omega, here omega is equal to I am writing a twice pi f naught, no problem. Okay. F naught is the frequency parameter. Then you can write f also, no problem. Everywhere you have to write f. Then n plus capital N plus theta. Can I write that this is equal to cos twice pi f0 into n plus theta? Yes, I can write this.
Sorry, periodic.
Here you see the left hand side is representing x n plus capital N. Okay, and this right hand side is representing xn. Now this will be equal to this under certain condition. Let us see what is that condition. And from that condition I can say, we can find out the condition for periodicity for this cosine or sinusoidal signal. Now you see here, if you write this left hand side, this left hand side is actually cos twice pi f0 into n plus, here you can write twice pi f0 into capital N plus theta. It is this is the left hand side. This is the left hand side. Okay, I am writing up the left hand side, not right hand side. It is left hand side. Okay. Now for this left hand side, let us consider that twice pi f naught capital N is equal to twice k pi. K is another integer. Then if you write this, then you see in this place you can write k pi. So this is equal to cos twice pi f0 small n plus twice pi k pi plus theta. So this equal to what I can do.
Sir, expand it, sir.
This is
Cos of
twice
x
pi
plus
k. So you can write simply it is
So
equal
what?
to cos twice pi f0 n plus theta. Is there any problem if you write this?
No, sir.
Suppose this plus this is equal to some phi. Then cos twice pi k plus phi. So this is equal to cos. This is equal to cos phi. And phi is equal to actually what I have written. Phi is equal to twice pi f0 n plus theta. So this is nothing but cos twice pi f0 n plus theta. So what I can write, this is equal to this. This is equal to this. That means this implies that x n plus capital N is equal to xn. Okay. So what is the condition we have assumed here? This is the condition. Under this condition, actually xn plus capital N becomes xn for this particular sinusoidal signal, cosine signal. Therefore, you see here from both sides this will be cancelled, this pi will be cancelled, 2 will be cancelled. That means f0 is equal to k by n. So f0 is equal to k by n. That means it is a rational number. K is one integer, n is another integer. So it is the ratio between two integers. Capital N not is equal to 0. Because we have considered that n greater than 0. Therefore, what I want to say that this signal cos twice pi f0 n plus phi, this signal will be periodic if and only if this f0 means the frequency becomes a rational number. So the conclusion is this, that it may be that in case of discrete time signal, the function is cosine, but it is not always periodic. It will be periodic under this condition if and only if this f0 frequency parameter f0 is always rational number. Have you got my point?
Yes, sir.
Okay.
Yes.
It is not always periodic. From the definition of periodicity of discrete time signal. So first you have to think what is the definition of periodic signal in case of discrete time signal. The periodicity of discrete time signal is this: x n plus capital N should be is equal to x n. If this condition is satisfied for any value or f n where n greater than 0, n is integer, n is always integer, then I will say that this xn is equal to xn is periodic. So this condition is satisfied for cosine signal if and only if this f0 becomes this k by n, which is rational number. But if f0 is a rational number, then this cosine function, though it is a cosine function, it is not periodic. Is it clear? Clear? Please.
Yes, sir. So,
Okay, now time is over. So, another, is there any class? Your next class is there, or I will continue for 5 minutes more to just complete this part?
okay, sir.
Okay. So here, just I want to show the graphs for, no, first you try to find out. Okay. Then it will be clear. All of you know, I think actually this C language. I will take one class for your practical lab. Actually here, the discrete time, here the signal and system, this lab, generally we take in computer, using computer, and it is possible to use a ready-made software, ready-made platform like MATLAB. You can use Python also, no problem. You can use C language also. But MATLAB is very user-friendly and Python is very user-friendly because so many libraries are already made for the signal processing, for signals and systems. Okay, so many functions are designed there. Now MATLAB, generally I like to use MATLAB, though MATLAB is not free, but however MATLAB is very user-friendly. Okay, and it is very easy for it is for us to write a code for any signals and any systems. Okay, and we can easily analyze the signals, different types of signals and different types of signals in different domain. Okay, now this xn, suppose xn is equal to here, suppose cos twice pi f0 n plus suppose here let us take like this simple, you neglect theta and think that this theta is equal to 0, then it will be easier for you to write a code. Okay, so for different values of n, you can find here and suppose let us take this here, this is actually omega 0. Omega 0 means twice pi f0. Let us first take omega 0 is equal to pi by 8. If you write omega 0 is equal to pi by 8, then actually what is f0? f0 is equal to twice pi f0 is equal to pi by 8. Then this pi will be cancelled out, then f0 is equal to 1 by 16. Clear? You take f0 is equal to 1 by 16. So if you take this, then you have to write here f0 is equal to 1 by 16. That means xn is equal to actually pi by 8. Sorry, let me write cosine function here. In this case, actually xn becomes like this, cos pi by 8 into n. Now you just try to take different values of n. Start from minus 50 to 50. You take this range of n. So find out the values for xn for n is equal to minus 50, minus 49, minus 48, minus 47, so and so up to 50. So you will get x of minus 49, sorry, x of minus 50. First you write 50, x of minus 50, you will get some value. Then x of minus 49, you will get some value. Then so and so. Then x0, n is equal to 0 for this. You will get some value. Here actually it is what I am writing. It is it is not x minus 50. I want to say, it will be x of minus 50, but the value of this can be calculated by this cosine pi by 8 into minus 50. So this will give you the value for x of minus 50. Okay, so for this actually using computer you can find out the values for these values, and then you find out the values up to x50. Then you plot this n versus. So for different values of n, you have got the values of xn, and then you plot. You will get a sinusoidal signal like this. A sinusoidal signal like this. You will get one sample value here, another sample. So you will get some sample values. So just I am arbitrarily drawing. You will get this kind of sample values. And if you just connect the peak points of these samples, you will get a sinusoidal signal. And it will give you the impression that the signal is sinusoidal signal. But if you take omega 0 is equal to pi by 4, that means you are increasing the value of omega 0. Then what will happen? You draw again, you find out the values of xn again and draw the graph, and you will say what is coming. Then again, you just take omega 0 is equal to pi by 2. And finally, you take omega 0 is equal to pi. So for each case, you draw the graph. You evaluate the values of xn, and you draw xn versus n. You will get different shapes of graphs. Okay. Now after that, you just try to analyze why the difference in the graph is coming. Why it is dependent on this value of the omega 0.
So frequency, sir.
It is a frequency, but ultimately, if omega is equal to pi, then what you will see, it will be something like this. Just I am drawing. আমি একটু ক্লাস নিচ্ছি, তো ক্লাস নিয়ে তোমাকে ফোনটা করছি, হ্যাঁ ঠিক আছে। What you will see that if omega 0 is equal to pi, then the signal structure will be something like this. Sorry, there equal distance. This distance equal to this distance, but it will be like this. It will not look like this sinusoidal signal for this case. You draw, you find out the values of xn and you draw it in using either MATLAB or Python. You try to see what is coming. Okay. And then you try to understand. I will not tell. You check it, you draw the graphs, and you try to understand why this kind of graph is coming. Okay. Now you have to understand that a signal is always function. So if you are strong enough to analyze the function, then you can analyze the signal, and from the signal you can extract different information which you need. Okay. So আজকে এই থাক today up to this. Okay.
Thank you so
Now
much.
I am not taking the attendance today because the time is over. So from the next day, actually, first I will take the attendance. Otherwise, it will be difficult for me to take the attendance. How many students are present today? Can you tell me?
145, sir.
145, na? Just
Yes, sir.
the device meeting address. 145. Okay. Okay. From the next day, I will take. So the participants is saying. Okay. From the next day, I will take. So if you have any question, you can ask me beyond the class actually, because it is 40 minutes class. So it will be difficult for me to actually complete the syllabus. So beyond the class, be free to ask any question. Okay. You read it carefully because this subject is basically based on mathematics. So you have to revisit the previous actually whatever you have learned in the mathematics subject. So you just Fourier transform, Laplace transform, Fourier series. Once again, you just recapitulate this from the mathematics books. Okay. Okay, I am leaving now.
Thank you, sir.
Okay, welcome.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Welcome.